All right, we're going to get into another element of prerequisite knowledge for Algebra 2 and hopefully be able to build upon this and get a good sense of almost everything that we're going to be doing. And the first thing I want to do is change one of these equations into an inequality. Very good. And then we'll be able to work from there. So just to review the instructions we've received so far. So far with prerequisite knowledge, I've given two sets of instructions. I've given an instruction called evaluate. And when I tell you to evaluate something, you are simply crunching numbers. The second thing I've told you to do is to simplify. And when I give you the instructions to simplify, that means we're using two things. We're using the distributive property, and we are combining like terms. And now we're going to get into a third instruction, and that third instruction is solving. Okay, so when we look at the examples that we're going to do, the directions read, solve the following for their variable. Okay, so we're going to be solving equations now. And so what we have to understand is how we solve equations and what does the solution mean, because that is a big element. So the first thing I want to talk about is how we solve equations. And the whole concept of solving is basically like solving a crime. You want to retrace your footsteps to go back to the scene of the crime, and it's the same thing with solving equations. When we solve equations, we're going to be doing a lot of what I call undoing. And what I mean by undoing is by using operations and their inverse operations. So, for example, when we undo something, we have to use the inverse operation. If we had a situation where we were adding, to undo adding, we use subtracting. To undo subtracting, we use adding. To undo multiplication, we use division. And to undo division, we use multiplication. Now, these are the basics of undoing. But with every operation, there is an inverse operation. So, for example, a more complicated operation would be something like raising a number to the second power. You can raise a number to the second power. That's an operation you can perform. And you can undo that operation by taking the square root. So you can also take the square root of something. That's an operation you can perform. And with the same token, if you are taking the square root of something, you can undo that operation by squaring something or raising it to the second power. And there are also things called raising to the third power, and there are things called taking the cube root or the third root. You can raise things to the fourth power, and you can take the fourth root and the fifth root. And as we move along Algebra 2, you will see we come into quite a few new operations that we weren't quite sure existed before, but we can undo those operations. And that's the whole purpose of solving. So when you read solve, you're thinking undo. When you read evaluate, you're crunching numbers. Simplify, just distributive property, combining like terms. Solving, you're undoing things. Now, what you have to understand is what a solution is. A solution is the value of the variable that would make a true statement. The value of the variable that would make a true statement. Now, I'm going to amend this definition because we have to understand that sometimes there is more than one solution. Okay, so instead of saying just the value of the variable, we can say the value or the values, because sometimes there's more than one. Okay, so we have the values of the variable that would make a true statement. Okay, so that is what a solution is. And now a true statement is a statement that has the left side being equal to the right side. And that is a true statement. And if we're using inequalities, we can still have true statements if the left side is less than the right side or the left side is greater than the right side. Just a true statement is something that is equal. So for example, 2 plus 3 is equal to 5. Right? That is a true statement. 5 is equal to 5. Okay, so the solution is when you're dealing with a variable, and the solution of that variable is the value or values of that variable that would make a true statement. And so that's what we're talking about when we're talking about solving. Okay, so I'm going to give you 3 examples to play around with for the basics of solving equations. So the first example, we have 5 minus 3x equaling negative 25. And so we're going to find the solution to this equation. We're going to find the value of this variable that would make this statement true, that what's over here is equal to negative 25. Now, how do we do this? Since we're solving, we are undoing. Okay, so we're going to seek to undo the variable. Now, the way we undo variable, just like I mentioned before, is retracing our footsteps. We have our variable here, and we see what is closest to it, and then what is furthest away from it. Okay, but we're going to deal with sides. Okay, so with this equation, we have 2 sides. We have a left-hand side and a right-hand side. And we're going to focus on what's happening to the variable. So to undo, we have to undo in the backwards order. So the closest thing to the variable is the minus 3. The furthest thing to the variable is the 5. And so what we have to undo is the 5 first. You work backwards. You retrace your footsteps. So the furthest thing away is the first thing you take care of. So the first thing we have to undo is that 5. And how do we undo this 5? Well, it's just a 5. So if we're going to undo it, we simply take it away. So all we're going to do is take away that 5. So we take away the 5 by, seriously, taking it away. Take away 5. And based on the subtraction property, addition property of equality, if we subtract 5 on the left-hand side, we have to subtract 5 on the right-hand side, and that will make our equation still valid, still balanced. So when we take this 5 away, we still have left this. This is a minus 3x. Okay, and then when we look at this side, we simply read it out loud. Negative 25 minus 5. And that will give us negative 30. So we have negative 3x is equal to negative 30. And again, the x is, so we don't know what x is. We want to get it by itself. We still have to undo. Now, we have to undo this. So the closest thing to the x is this negative 3. How do we undo this negative 3? Well, currently, what is this negative 3 doing with the x? What this negative 3 is doing with the x is multiplying. That is multiplication that's happening there. So if we're going to undo this multiplication, what we have to do is divide. And so we're going to end up dividing both sides by negative 3. So we start here. We're going to take care of this. We're going to undo that negative 3. Since it's currently multiplying, we're going to divide by negative 3. And that will retrace our footsteps to isolate the x. However, if we divide the left-hand side by negative 3, we have to divide the right-hand side by negative 3. Now, what is going to happen here? Negative 3 divided by negative 3 equals positive 1. And positive 1 times x is equal to x. And x is all of a sudden by itself. And then on the right-hand side, we have negative 30 divided by 3, which is positive 10. And so we have x equals 10. And remember, what is a solution? A solution is the value of the variable that will make a true statement. So what we can do is test this solution. We can test x equals 10. And how? We can plug the 10 value back in for x to see if we have a true statement. So if we have 5 minus 3 times x, or 5 minus 3 times 10, will that equal negative 25? And so we have 5 minus 3 times 10. Remember, we have to multiply before we add or subtract. So we have 5 minus 30. Does that equal negative 25? And of course, 5 minus 30 is negative 25. So yes, this is very much equal. That means the value for the variable that would make this a true statement, the only value for this variable that would make this true is x equaling 10. So there is our solution. And that is how we approach solving equations. We undo things. And we'll get into more complicated equations later. I just want to do a prerequisite knowledge. So now, what if we're not dealing with equations? What if we are dealing with inequalities? So we have an inequality statement, which is in the second example. We have negative 6x plus 12. And how do we read this symbol? Less than or equal to. Less than or equal to. Okay, so that's less than or equal to 36. And we're going to find all the values for the variable that makes this statement true. Okay, so if we're solving, we are still undoing. Okay, we're solving, we're still undoing. So that's the goal. We're going to identify x, and we're going to undo all those things that are happening to x. So here's the x, and here are, again, the left-hand side and the right-hand side. Okay, so we have a left-hand side and a right-hand side, and we begin to undo. What's currently happening? What's the closest thing to this x is this minus 6. What's the furthest thing from the x is the plus 12. And so solving, retracing our footsteps, we deal with this first. The furthest thing away, we deal with first. So we're going to undo that plus 12. And how do we undo plus 12? Of course, with minus 12, the inverse operation. So the first thing we're going to do is subtract 12. So if we get rid of that furthest thing away from the x, we'll be okay. We'll start making our way to the solution. If we subtract 12 on the left-hand side, we subtract 12 on the right-hand side, and we will be left with negative 6x is less than or equal to, and then read this out loud, 36 minus 12 is 24. And now what we're going to do is continue solving for x. We still have to undo something else. The x is not by itself, so we still have to undo. We have to undo that negative 6. But again, what is happening between the negative 6 and the x? What is happening right there is multiplication. So if we're going to undo that minus 6x, we have to undo multiplication. And the way we undo multiplication is division. So we're going to divide by negative 6 to undo the variable. And if we divide on one side, we have to divide on the other side. And here comes a very important note. When it comes to inequalities, and this should be a review, but when it comes to inequalities, if you divide or multiply both sides of an inequality by a negative, if you divide both sides of an inequality by a negative, the inequality symbol flips. The symbol changes direction. And so that is the note that must be remembered. Okay, so if we're dealing with inequalities, when we divide both sides by a negative or multiply both sides by a negative, the symbol changes directions. Okay, so in this case, We divided both sides by a negative number. So the inequality symbol is going to go from less than or equal to greater than or equal to. And just like before, we have on the left-hand side, negative 6 divided by negative 6 is positive 1, and positive 1 times x is x. X is now isolated. On the other side, 24 divided by negative 6 is negative 4. And so we have x is greater than or equal to negative 4. So that's how we read it. X is greater than or equal to negative 4. And again, what is a solution? A solution is all the values of the variable that will make a true statement. So if we have our solution, x is greater than or equal to negative 4, how can we test that? Well, the way we can test that is to pick any number that's greater than or equal to negative 4. So a number that's bigger than negative 4 is 0. So let's say we can test 0. And you can test any number that's greater than or equal to negative 4. You can test negative 4, you can test negative 3, negative 2, negative 1, you can test 1,000, you can test 1,000,000. But either way, pick a number that's bigger than negative 4, plug it in for x. And again, I like using 0. 0 is a fun number to work with because it's so easy to work with. And so we plug in 0 for x because 0 is bigger than negative 4. And then we're going to see, do we have a true statement? So negative 6 times 0 is 0. And is 0 plus 12 less than or equal to 36? Well, yes it is, because we have 12 less than 36. Okay, so 12 is totally less than or equal to 36. So this is a true statement, totally true. And again, the value for the variables that makes the statement true. So x is greater than or equal to negative 4. That means x is any number greater than or equal to negative 4. And that's what this symbol means. X is everything greater than or equal to negative 4. And that's what would make the inequality statement true. All right. Now, for one last example, this one's going to be kind of fun. I'm going to show you a couple things that I find interesting. So for this last example, we have a little bit of work to do first. We have an inequality. X is greater than 49 plus 6. So with this inequality, again, we're still undoing stuff, but undoing what? So here comes a rule that's going to come in later in later notes. Before we undo things, what we should do is simplify first. So before we undo things, we should simplify first. And again, we look at this inequality with a left-hand side and a right-hand side. So on the left-hand side, is there anything to simplify? On the left-hand side, we have 11x. We cannot get simpler than that. That's all we can do. So on the left-hand side, we have 11x. On the right-hand side, we have 49 plus 6. Can we simplify that? Well, hopefully you heard what we just said. 49 plus 6. 49 plus 6 happens to be 55. So we can simplify that side. We get 55. And we haven't changed anything. We haven't divided by a negative, so the inequality symbol remains the same. And now we have 11x is greater than 55. Now we can undo. And so we undo the 11, because we're keeping our eye on the x. We undo the 11. And again, that's multiplication happening there. And since that's multiplication happening there, we undo by dividing by 11. And so we will divide by 11. And if we divide the left-hand side by 11, we have to divide the right-hand side by 11. 11 divided by 11 is positive 1. 1 times x is x. Do we change this inequality symbol? No. Only if we were dividing by a negative will that symbol change. It's still greater than. We're dividing by a positive. And then 55 divided by 11 is 5. So x is everything greater than 5. And that's what would make this a true statement. So x is greater than 5. And that is the concept of solving. So we want to undo things for solving equations. And hopefully that will help us get ready for more Algebra 2.